important scientific satellite ever put into orbit, the Hubble Space Telescope, enabled astronomers to view stars and galaxies in previous unimagined detail. Its optics and systems have been continually upgraded by shuttle missions. Hubble has even enabled astronomers to begin diving the origins of the universe. Introduction. In space, a satellite is an object locked in orbit, following its curved path around a more massive object. It was long understood that the moon orbited the Earth in this way. A method for placing artificial satellites in orbit around Earth was first suggested in 1903. 50 years later, or 50 years passed until the technology was ready. The beeping Sputnik 1, speeding up to 17,000 miles or 25,000 kilometers per hour, circled the globe. More than 3,000 satellites from 50 different countries have since been placed in orbit, forever changing the way we see the world, communicate, and view the cosmos. Below, you see a picture here. A Boeing Delta IV heavy lift vehicle or rocket blasts a U.S. GOES weather satellite on its journey into orbit. The Delta is one of several orbital launches used by the 10 or so spacefaring nations. An average of 120 satellites are launched every year. I skipped a couple of pages in this book. If you would like to read it in its entirety, you can always go on Get Epic. I will post the name of the book. But I'm going to read these 2 pages, and I want you to write down in your notebook some things that you notice and wonder about the images. Earth imaging. During the early crewed space mission, astronauts remarked on the surprising amount of detail they could see on Earth's surface. This led NASA to develop dedicated Earth imaging satellites. Global surveyors. The USA Landsat program has been using satellites to take pictures of Earth's surface continuously for the last 40 years. Landsats fly 560 miles or 912 kilometers up on a sun-synchronous polar orbit. The altitude is high enough for a global view, but low enough to show humankind's impact on the environment. The photographs are stunning, but the valuable data is from spectacular scanners. These record invisible wavelengths of light like infrared and ultraviolet, revealing hidden details. Landsat is used in farming, map making, forestry, urban planning, climate effects, and mineral exploration. In 1972, Earth's Resources Technology Satellite, ERTS, later renamed Landsat 1, was a Nimbus weather satellite equipped with a special video camera and a cutting-edge, for its time, multi-spectral spectral scanner. Landsat 8 is a thermal infrared sensor. 2 is an operational land imager. 3, it's a booster rocket. 4, it's a reaction wheel. Landsat 7 and 8 complete over 14 orbits per day, covering the entire Earth every 16 days. If I had to pick one spacecraft development to save the world, I would pick Earth's and the satellites which will follow. And that was by Dr. James Fletcher. He was the leading person in NASA in 1975. Areas like Hawaii with active volcanoes are of particular scientific interest. This false colored image, gathered from multispectral instruments, will also be used to plan future resort buildings and changes in land use. Through the keyhole. Nations can use land imaging satellites for spying. The U.S. spy satellites were designated KH or keyhole, and until the 1980s had photographic film. Used film canisters would separate from the camera ship and re-enter Earth's atmosphere, floating down on parachutes to be snatched in mid-air by aircrafts. At least 4 KH-12 satellites are still alive and may have formed the basis of the Hubble Space Telescope. Technical details of current government spy satellites remain classified. So take a few minutes, look at these pictures, and then write down the things that you notice and that you wonder. We're going to continue on reading. But as I read these pages, I want you to jot down some of the ideas that you see of how satellites can help predict weather. Okay? Weather satellites. Modern day meteorologists' satellites have made short range weather forecasting highly accurate. From heat waves to hurricanes, weather satellites provide plenty of warning. Bulletin board. The animated satellite images seen on TV, weather reports, come from a fleet of 3 active satellites hovering over the American continent. These advanced geostationary operational environmental satellites, GOES, are run by the National Oceanic and the Atmospheric Administration, otherwise known as NOAA. GOES has several main instruments. A multi-channel imager looks at infrared energy and reflected sunlight in the atmosphere. A sounder gathers vertical data for temperature and moisture, as well as ozone density. GOES can also monitor space weather like solar flares and magnetic storms. In 2005, GOES satellite images of Hurricane Katrina provided hour-by-hour updates on an unfolding weather disaster. The latest fleet of GOES cost $10.9 billion and begins launching in 2015. In 1982, polls are credited with saving more than 17,000 lives by detecting and locating emergency beacons from people in distress. Let's look at this map right here, or satellite imaging here. This infrared image of Hurricane Andrew making landfall on the tip of Florida was taken by weather satellite GOES 7 in 1992. 20 years ago, hurricane forecasts were issued just 3 days ahead of the landfall. Now they are available 5+ days in advance due to more numerous satellites and more powerful computer models. Seeing the whole. While GOES scans the western half of the globe, other satellites complete the whole picture. NOAA's constellation of polar operational environmental satellites swing up and down around the poles. They provide data to make long-range forecasts and climate predictions for shipping, aviation, farming, and the energy industry. POLE's equipment includes a transponder to receive and retransmit SAR, search and rescue, beacon signals. It also gathers scientific data from ocean bios and weather balloons. Countries without their own sophisticated weather radar rely on poles for their weather predictions and warnings. Research satellites. Recent cuts in space budget coincide with rising concern about global warming. NASA's planetary experts were tasked with examining Earth's climate system for some firm answers. Remote sensors. NASA's Earth observing system began in 1999 with the launch of the multinational satellite Terra. Loaded with various kinds of spectral analyzers, Terra gathered information on ozone, which shields Earth from the sun's ultraviolet rays, and pollution. Aqua studies rainfall and evaporation using instruments similar to weather satellites. Aurora scans atmospheric layers and air quality. Aurora and Aqua orbit with others in close space constellation, the A Train, building high definition 3D images of Earth's surface and atmosphere. Nobody on this planet is going to be untouched by the impacts of climate change. Climate Quest. Worldwide information on the chemical makeup of the atmosphere changes in polar ice sheets, and water and carbon cycles are combined to produce long-term climate predictions. Science accepts that over the next few centuries, our planet will get hotter, but much remains mysterious. Further satellites launches should fill some gaps. NASA's orbiting carbon observatory, part of the A Train, will make those detailed measurements yet of global carbon dioxide and other greenhouse gas levels. The forecast for the next 90 years is generally wet, with drier places becoming more arid and wetter places getting swamped. So we refer back to page 19. In the panel, it says, nobody on this planet is going to be untouched by the impacts of climate change. What do you already know about global warming? What questions do you have about global warming? And how do you think we can use infrared satellite imagery to help solve the problem with global warming? All right. After listening to this book, you are going to create a discussion post and you're going to answer what other questions do you have about the technology that we use to help predict the weather and future natural disasters.